We talked about this yesterday, but I said that at some point they're going to get to be able to like merge all these different things into all the different properties that you can get the same answer multiple different ways, right? So one way for that first one is move the 125 to the top, making it negative exponent, right? And then rewriting that as 5 to the negative 3. Then 5, log base 5 of 5 to the negative 3 will be negative 3. That's what we did before. Because it said rewrite and simplify, I'm just going to expand it so that we can practice that, okay? So I would rewrite it as log base 5 of 1 minus log base 5 of 125. And then what is log base 5 of 1? 0. What is log base 5 of 125?
Wait, how did you know this 0?
Because if the big number's 1, it's always 0, right? The only power I can raise something to get it to be 1 is 0. This would be 3. Yeah, I just said that. There's multiple ways to do this. Just because it said rewrite and simplify, we're going to practice the expansion. It should be negative 3.
So anything to the 1?
When the big part is 1, it's 0. Yep, no matter what that base is. So when it gets to the point, if it said simplify, you could do that any way you wanted. Okay, again, you could rewrite it so that it's 25 or 125 in the top with the negative exponent. Then that would be 5 to the negative third. And cancel it out, you'd get negative 3. So how you choose to do that is up to you, unless it literally said expand and simplify. If it said expand, then it wants you to obviously expand it.
So for these, can you just like into yourself 1 over like to the power?
Yep.
Give you 125.
Yep.
Just a fraction to the negative?
Yep.
Okay.
Number 2, again, there's multiple ways to do it. One thing I could do is bump the exponent to the front. So I could rewrite this as 2 ln of e plus L plus 5 ln of e. And then what is ln of e? What happens there? It cancels to just give you the exponent on the e, which would be a 1. This would be 2 plus 5, which is 7. That's one way to do it. The other way is not even bump the exponent to the front at all. If it's ln of e with an exponent, I just keep the exponent. So this would just be 2 plus 5, which is 7. Yep.
I thought that since you were adding them, you had to like...
You could also condense it. Is that what you did?
But then I got 10.
So this would be what it is condensed.
I thought it was
If it's addition, it becomes multiplication.
Right.
And then when you have the same base and you're multiplying, you add the exponents.
I thought you just like multiplied them together. So
Only when you raise the power to a power do you multiply. So this, again, you could cancel, keep the 7, or you could bump the front, and ln of e becomes 1. Doesn't matter how you do that. All the different ways should result in the same answer. So if it said 3 ln e to the second, this 2 would get multiplied by that. So it'd be 6. Plus 5? Plus whatever's there.
Wait, what did
She said, what if there was a number on the front? The exponent would get bumped to the front and you'd multiply those 2 numbers together.
But the ln and e would still cancel.
It cancels out, giving you 1, it gives you its exponent. So it's not gone, it's not 0, it gives you the exponent. Yeah. Olivia.
How did you know to do that and not to like...
You could, honestly, when I say simplify, you could do it any way you want. If it said condense and simplify, then you got to get it down to 1 ln.
Like I put the answer as ln and then...
Oh, you always want to get rid of it. If it's ln of e, you're going to get rid of it.
Okay.
Yeah. Because even if you condense it, it should have been like this. This is what you got, like ln of e to the second times e to the fifth. That can be simplified. You just want to keep going. Okay, then 3 said expand. So this is multiplication. When I spread it out, it becomes addition. That would be ln of x plus ln of y plus ln of z to the second. And then the 2 bumps forward. So ln of x plus ln of y plus 2 ln z should be your answer. No, because it's only on the z. If this was in parentheses, then the 2 would go to all. And then 4, remember anything in the denominator gets the minus. So this becomes log base 5 of x squared minus log base 5y squared minus log base 5z to the third. And then all the exponents bump forward. 2 log base 5 of x minus 2 log base 5 of y minus 3 log base 5 of z.
If you had a negative in the denominator, like would it be positive?
A negative what?
Like let's say the y squared was negative.
It can't, because you think you can't find a log of a negative number.
Okay.
Yeah.
So that never will happen?
It happens when we get into solving, but you'll know you can't do it, which is next section. Not quiz. Yeah.
So whenever you're expanding, you put the exponent to the front.
Correct. So an expansion can't have a power. It's got to get bumped to the front. And a condensing can't have a front. It's got to get bumped to the back. It's the reverse. Yeah. It's whatever it is from the beginning. So like if this was in the top, now only the y squared would be negative. Because it's whatever in the bottom. So whatever's in the bottom gets the negative. Whatever's in the top gets the positive. Yeah. Okay. There are two different types of graphing, right? There was exponential, which is what we did in 3.1, and then there was log. So exponential does not have the word log in it. It's the easiest way to identify it. It could have an E, it could have a number, right? But it does not have the word log or ln because ln is a log. Log is going to literally have the word log or the ln in the question, right? So for exponential, we plug in for x. For log, we plug in for y. That's the first major difference. For exponential, there is a horizontal asymptote, and it is based on the vertical shift. So if I had f of x equals any base, 3 to the x plus 1, if there's a number that is added or subtracted after the function, so it's not in the exponent, that's causing my vertical shift, right? So this would be y equals positive 1. We don't change the sign on the vertical shift. If it said f of x equals 3 to the x plus 1, and it's in the exponent, that does not cause a vertical shift. This would be y equals 0. If it was f of x equals 3 to the x plus 1 minus 2, now it's at negative 2. So all of those could also have been e's, e to the x plus 1, and that's the same as that. F of x equals e to the x plus 1 in the exponent, and it's the same as the second one. And f of x equals e to the x plus 1 minus 2, and it's the same as the third one. Same as in horizontal asymptotes. Obviously, the coordinate points are going to be a little bit different. Not much different, though, because the base of 3 is not that different from E. E is just 2.7. These you would use a calculator on, and it will say to round your coordinate points to the nearest tenth. These you don't need to use your calculator on, and it will tell you to make them exact. So be careful. If your answer is like a 1/3 and you type that in the calculator and you give me 0.3, I'm going to dock points. You want to be able to do these things without a calculator because tests are going to be separated. Your domain on all the exponential is all real numbers. Domain, negative infinity to positive infinity. Range is also based on the vertical shift. Okay, it starts wherever the asymptote is, and then it either goes to positive infinity if it's facing up, or it goes from negative infinity to that if it were flipped upside down. None of these have been flipped upside down so far, but it can happen.
Is it going to be on the quiz?
No. You could have a base that's a whole number. You could have a base that's a fraction. There are both of those on the quiz review. We've done both of those. Okay, so you've got to know how to do all that stuff. And then it's going to ask for your y-intercept, which comes from the middle coordinate on your t-chart. So if you fill out your t-chart, your answer's already there. You just got to rewrite it.
But you always plug in negative 1, 0, and 1.
Yeah.
Even when like those numbers aren't included in the range.
They will. Because your domain's never going to be restricted on exponential, and so you're plugging in for x. It's never going to have a restriction. You can always plug in negative 1, 0, and 1 into the x, which is why we flip-flop for the log, because the log is different. The log, it gets messy when you're trying to figure out what the x is. That's why we plug in for the y. There's no restriction on the range, so you can always plug in negative 1, 0, and 1.
And for the range on exponential, it's just the number. So like for the first one, it would be 1 common thing.
Correct.
And for this quiz, it's always going to be to infinity.
Yeah.
It's going to be negative.
So then log for the exponential. Logs we have done where they have flipped. Okay. Logs, you're going to get the log on the side by itself first. So if I had log of x plus or minus something, minus or plus or minus something, I have to get rid of that first. I'd have to move that to the other side. And then you convert to exponential, which is an example that's on the class kick. I'll get to that in a second. This time, your domain comes from your horizontal shift, okay? Which means there's a vertical asymptote. The vertical asymptote's by setting whatever's in the parentheses equal to 0.
Can you explain the log plus or minus the number?
Like if there's a number here, it causes a horizontal shift, which causes a shift in my vertical asymptote and my domain. If there's a number after it, or even before it, or there's a negative on it, I have to get rid of those things before I convert it into exponential, but it doesn't affect my vertical asymptote. Only the horizontal, which is inside the parentheses next to the log, causes a shift on my vertical asymptote. And then this time, you get a x-intercept, and it comes from the center part of your t-chart. The range here is negative infinity to positive infinity. So domain of the first, range of the second. And this is true for log or ln, because ln is a log. The directions are literally going to match, like they did on the warm-up and the class kick. They're going to match what you should get. If it says x-intercept, you should get an x-intercept. If it says domain and range, it's going to be the same for both. But if it says vertical asymptote, there should be a vertical asymptote. And if it says horizontal, there should be a horizontal. I'm not trying to trick you, okay?
So the domain is just the number, common infinity?
As long as it's pointing to the right. If there was a negative on the front or a negative inside, it could flip it left. So you got to look at your graph. But the number is the number part is the same as your asymptote, which is,
And the asymptote is just a number?
yep. Well, the opposite of the number that starts with. Because you set it equal to 0. If it said log of x minus 10, then x equals 10 is my vertical asymptote. And my domain, this is positive, so it's going to be 10 to positive infinity.
But for, like, let's say you did the same thing for exponential, but it was like an e instead of log, it'd be y equals...
Wait, you just said for exponential, but if it's an e instead of a log. Which one are you talking about? You're talking about the ln?
Let's say it was e x minus 10, like for exponential.
In the exponent?
No, like exactly how you wrote it over there.
So you're saying ln?
No, e.
No.
Like, it would just be x equals 10.
That's what you're confusing. Log and exponential are two. So if it's an e as a base, it's exponential.
Right.
If it's ln,
I'm just
then
saying
it's
how
log
you
base
would write
e.
it. You would write it y equals negative 10 if that was written in exponential.
Then it would be this.
Right.
Yes. Yes. Okay, so this is the first one, okay? You set up a t, it's exponential, so you go straight to the t-chart, plug them in. -1 would give me 1, 0 would give me -2, and 1 would give me -2 3/4. You can plot those points. Then you want to look for your horizontal asymptote, which comes from the vertical shift. It's the opposite, right? Like horizontal leads to vertical, a vertical leads to the horizontal. So if it's -3, it's shifted down 3 places. And so my horizontal asymptote is at y equals -3. That y-intercept comes from the center of my t-chart, which is 0, -2. It's exponential, so domain is all real numbers, negative infinity to positive infinity. And the range matches my asymptote from -3 to positive infinity. Domain and range all get parentheses. Don't write a single bracket on this quiz. E to the 1 minus x minus 3 is still exponential. It's just that the base is e. So I plug in the -1, the 0, and the 1. I get -1 and 4.4, 0 and -0.3, 1 and -2. I plot those points. Vertical shift is now -3, so my horizontal asymptote is y equals -3. You need the y equals.
Wait, you said 1 -2?
Yeah. When you plug in 1, you get e to the 1 minus 1, which is e to the 0. That's 1. 1 minus 3 is -2. So then I would draw my asymptote. Then I would draw my curve, making sure I make it curve and it gets close to that asymptote. Domain, because it's exponential, all real numbers. Range goes from -3 to positive infinity. And the y-intercept is 0, negative 0.3. Then I get to question 3, and I approach this differently because why? Because it says the word log. The word log says, hey, you're plugging into the y here, okay? So I plug in -1, 0, and 1. But before I can plug in, I have to add the 2 to both sides. So I get this, y plus 2 equals log base 2 of x minus 1. The 2 comes over and picks up this whole thing, now becomes the exponent. I get 2 to the y plus 2 equals x plus 1. And then I solve for x, so I add the 1. And now I'm plugging into this. So I plug in -1, 0, and 1. I get 2 to the first plus 1, which is 3. I get 2 to the second plus 1, which is 5. And I get 2 to the third plus 1, which is 8 plus 1, or 9. Then I plot those points. The vertical asymptote comes from what's inside the parentheses. So I set that equal to 0, and I get x equals 1. My domain is caused by the same shift. It's 1 to positive infinity. My range is -infinity to positive infinity. And my x-intercept is 5, 0. Okay, then it's an ln, which is a log base e. So again, I'm plugging in for -1, in for the y, -1, 0, 1. Before I do that, I have to move the 2 to the other side. So I subtract it from both sides. Then I have to get rid of the negative on the front. It's got to be completely, that log's got to be completely by itself before I can convert it. So then I would multiply everything by -1. That changes it to this. Okay, -y plus 2 equals ln of x. ln becomes log base e. The e comes over and picks up this whole thing as its exponent. And I get x equals e to the -y plus 2. Plug in -1, plug in 0, and plug in 1. And I end up with e to the third, e to the second, e to the first, which is 20.1, 7.4, and 2.7. Because why is it? Because after I moved the 2 over, so it was -2, I had to get rid of this negative, so I multiplied everything by -1. You can do it first, but then it would have been, so if you get rid of the, by multiplying by -1 here, I get -y equals ln of x minus 2. It still affects that 2. You got to do the whole equation. Hang on. So the vertical asymptote, this is just x. So it's x equals 0. The horizontal asymptote. The domain is 0 to positive infinity. The range is all real numbers because it's a log. And the x-intercept comes from the center part of your t-chart, which is 7.40.
Why isn't the domain and the vertical asymptote 2?
Because it's based on what's attached to the log or in parentheses next to the log. That plus 2 is a vertical shift. We're looking for a horizontal shift. This should be vertical. It's at x equals 0. No, there is one. It's x equals 0. X equals 0 is an asymptote because there's nothing inside the parentheses with the x. Came up in the last class, right? So 8100, you'd have to break down, right? That's 80. Ooh.
And then 3, and then see how many times.
Right. So this is 81 and 100. This is 9 and 9, which is 3 and 3 and 3 and 3. That's 10 and 10, 2 and 5, 2 and 5. So there's 1, 2 2s. There's 4 3s. And there's 2 5s. So you can rewrite it like that, right? Then you can expand it. Log base b of 2 squared plus log base b of 3 to the 4th plus log base b of 5 squared. Bump all the 2's to the front. And then replace what they gave you. So 2 becomes this one. 3 becomes this one. 6,
Then
4, 6.
You want to see what the whole like log be?
Yep.
Okay.
And then you'd multiply all that out, add it together, and that's where that comes from. So this I actually didn't put on your quiz. I'm pretty sure I'm going to pull it back in on the test, though.
Okay.
Yeah.
No, I was just curious because I saw.
Yeah, I did it so much.
I like how. I guess like.
So those I don't usually cry. I go, what did she do? That's what I do.
I mean, I thought when I got.
This was 4. So 4 looked like this. I would separate this out as log 3, 8 to the 3rd, plus log 3, 9 to the 8th. Bump the exponents forward. 3 log base 3 to the 8th, plus 9. No, that's not a 9. Sorry, can't even see my own handwriting. 8 log 3 to the 9th, and then log base 3 to the 9th is 2. 8 times 2. Good? Yeah. Okay. So, okay. This is it's the quiz review. The graphing is like at the beginning, and then I added some on at the end too. So we start exponential, you get to log. Think that they could be mixed together, and you got to look for it, okay? You are going to get 3 total graphs, a makeup of logs and exponentials, okay? There's going to be obviously 3 different ones. You've got to be able to answer all the parts that are in the question. And then this all came from 3-1, where you were just doing that mental math on the simplifying. That's going to be part of it. On the second page, you've got your expand and condense, which is the stuff from yesterday. You've got your interest problems, which was from 3-1, okay? And then the natural log and common log ratio, or the change of base, that was from 3-3. That was from yesterday. The formula is not going to be given to you, so you make sure that you know that formula. And again, I said it before, but every time you do that problem, rewrite that formula. It'll help you remember it. Remember, it's one formula for like A through E, and then it's another for the continuously. And then the last 2 graphs I added on, LN and E. These are the ones that you're going to use your calcs on, and you're going to round to nearest 10th. So obviously the interest ones, you need your calculator. That's money. You're going to round it to the nearest 100th. Anything else, like the change of base, it will tell you what to round to, and then the graphs are going to say nearest 10th.